everyone! This is our gas law chemistry project. This was made by me, Flame Valentine, Gabriella Norris, Elizabeth Manders, Amaya Duran, and Fullen Majors. Before we officially get started, here are some things you should know. Volume is always in yellow, pressure is always highlighted in red, and temperature is always highlighted in blue. Okay, that's all. I hope you enjoy!
Firstly, we're going to talk about Boyle's law. Boyle's law explains the relationship between pressure and volume. Simply put, as pressure increases, the volume decreases. They're inversely proportional to each other. The formula for Boyle's law is P1 times V1 equals P2 times V2. For example, a gas occupies a volume of 5 liters at a pressure of 1.5 atmospheres. If the pressure is increased to 3 atmospheres, what is the new volume of the gas? In this question, since we're trying to find the new volume, we need to get V2 by itself. In order for this to work, we need to divide P1 times V1 by P2. Now that that's done, we can plug in our numbers, which gives us 1.5 ATM times 5L divided by 3 ATM. And your final answer should be 2.5 liters.
Now moving on to the next law, Charles' law, which states that the volume of a gas is directly proportional to its Kelvin temperature when the pressure and amount of gas are kept constant. If we were to refer back to Mr. Rodriguez's video, you would know as temperature increases, volume increases, which is explained by the kinetic molecular theory, higher temperature equals more collisions equals same pressure, which makes up our beautiful, amazing formula. Initial volume over temperature would equal second volume over temperature. Now, an example. A 275 milliliter balloon is filled with air at 25 Celsius. If the temperature increased to 50 Celsius, what is the new volume of the balloon? Well, first we have to make sure to underline and box the important information, the given amounts that we have, and make sure to write it down to the side what we have. So for initial volume, we are given 275 milliliters. For initial temperature, we are given 25 Celsius. And for second temperature, we are given 50 Celsius. We have to make sure to convert the Celsius to Kelvin because as we are using this formula, it is called for Kelvin, not Celsius. So we would add 273 to 25 and 50 to get 295 Kelvin and 323 Kelvin for our initial and second temperature. Next, we have to make sure to rearrange our formula so we are given the second volume as we don't have that information, and that is what we are looking for. So if you were to move it around, you would get the initial volume and second temperature over the first temperature to get the second volume. Now, after plugging everything in, you would see that it would be 275 milliliters times 323 Kelvin over 295 Kelvin, which would give us 298 milliliters. So for our second volume, we would get 298 milliliters.
Lusak's law describes the relationship between the temperature and pressure of gases. Pressure is directly proportional to temperature. In other words, as pressure increases, temperature increases. Here's the formula for this law. P1 over T1 equals P2 over T2. Here's an example problem. The first step to solving this problem is to write down everything we have. We have temperature 1, pressure 1, and temperature 2. For the temperatures, we convert them from Celsius to Kelvin by adding 273. The next step is identifying what you need. We are looking for pressure 2. Then reorganize the equation to fit the problem and fill it with what you have. Now all you have to do is solve it. The second pressure is 3.31 ATM.
Okay, next we're going to talk about the combined gas law. The combined gas law is a formula that relates to pressure, volume, and temperature of a gas under different conditions. Now let's look at this combined gas law example. A sample of gas has a volume of 15.0 liters at a pressure of 1.0 atm and a temperature of 300.35 Kelvin. What is the volume if the pressure is raised to 2.8 atm and the temperature is raised to 356.2 Kelvin? Okay, so first, if we're doing any gas law problem, we have to look at the problem and see what our givens are. And after looking at the problem, we can see that our givens are pressure 1 is 1.0 atm, pressure 2 is 2.8 atm, volume 1 is 15.0 liters, volume 1, or temperature 1 is 300.35 Kelvin, and then temperature 2 is 356.2 Kelvin. And now we need to look at what we need and what we're solving for. And in the equation it says, what is the volume? So we know that we're looking for volume 2. And after establishing our givens and our needs, now we're going to look at what equation we're using. And since this is a combined gas law example, this would be the combined gas law formula, which is P1 times V1 divided by T1 equals P2 times V2 divided by T2. And since we're trying to find volume 2, we must rearrange the problem to get that answer. So what we do is we divide P2 on both sides and then multiply T2 on both sides. And since we rearranged the problem to solve for V2, now we can finally plug in all the numbers from our equation into a formula, and then we can solve it. And when you're plugging that into the calculator, you have to make sure that you have brackets on each number to make sure that you get the right answer, because if you don't, you might get a completely different answer. So you have to make sure that you have those brackets. And then after plugging it into the calculator, you get 8.6 liters.